we have got the behavioral graph question. The diagram below is a speed time graph of a car. The car starts from rest and accelerates uniformly at 2 meters per second squared for t seconds until it reaches a speed of 16 meters per second. It then travels at 16 meters per second for 40 seconds, after which it comes to rest in a further 10 seconds. So from this point of 0 up to the point it reaches 16 meters per second, it is t seconds. Then here from t, it has traveled for 40. So at this point, it is 40 plus t at this point. Then last, it has traveled 10 seconds. So there is a 40 and then there is a 10. So this is 50 seconds for the last part. But the first part, we have been told just a t. So that's how the question is. So another thing that has been mentioned is that the object started from 0. Then it moved with the uniform acceleration, which was 2 meters per second squared. So here along a straight line, the acceleration everywhere here is 2 meters per second. That is the acceleration. Then this side it will be positive because the object is increasing the speed. This side it will be negative because the object is reducing in the speed. Let's check this question. The first question is saying, find the value of t. Find the value of t. So we know t is time. So solution. Children, what is the value? What is the formula? What are we going to use?
Find the value of t.
Yes, to find the value of t. Okay. Acceleration equals velocity final minus velocity initial over the time which has taken place. Data. So from our information, what is A? Purity. What is A? A is acceleration. What is A? What is A? Yes, what is the value for A? Yes, okay. What is the value for A? Mio, what is the value for A? 16. Yes? 2 what? Correct. 2 meters per second squared. Then we go for V. V is the velocity final. The object started from rest, then it reached somewhere. So where did it reach? Come 16 now. 16 meters per second. U is the initial where the object, which speed did the object start with? 0. And then we have T as our only variable remaining to be calculated. So we shall use this data and then replace in this formula. So for A we have got a 2. So 2 equals velocity final. What's our velocity final? Yes, velocity final. 16. Very good. Initial 0 over t. Whatever can cross multiply can swap. So these two can cross multiply, hence they will also swap. So it will be 2 coming down. 16 minus 0 is 16. Then 2 comes down. And then our time will be 8 seconds. Any questions from how the answer has been calculated? You can copy down. At the back. We continue with the next question. So the next question is saying, calculate or find the distance traveled in the last 40 seconds or 50 seconds. Calculate the distance covered in the last 50 seconds. So Chirache, how do you calculate distance under the speed time graph? How is speed calculated? Or how is the distance calculated? Use the formula for distance, which is given by
B equals to one over two over 2 then bracket A plus B close bracket H.
So we are calculating area in what? So to calculate distance under the speed time graph, we need to calculate the area which has been covered. It's okay? That's how you answer. To calculate distance, we have to calculate the area. So area, that one is not a constant formula. It just depends on the shape which has been formed. So in our case, it's a trapezium, hence that's why we're using that formula. So if we check, we have been told the object starts from rest and moves for 2 seconds, and then 40, and then 10. So 40 plus 10, that is what is making 50. So we are going to calculate the area of this shaded part. That is the one who calculating. So the shaded part. So if you check the shaded part, it's a trapezium, whereby it has got the height, the short side, and the long side. So we have got the short side, long side, and the height. In that case, we have got a trapezium. So distance equals, we are using the formula for trapezium, which is A plus B and H over 2, whereby this is what we are following. This is our longest side, which is going to be our B, equals 50. Since from here to here it's 40 and then 10 seconds plus. So 50 down. Then top is just 40, which is A 40. And then the height. What's the height? 16, correct. So the height is 16. So after having that, we need now to replace in our formula. So that's what you have to do. Just to identify the shape which has been formed by the movement of the object. After I've identified the shape, identify its formula for area. Thereafter, also identify the data, then replace. So now we are replacing. So as you replace it, you don't have to simplify, just put the actual number. So your A is 40. So you can add those which are in the brackets and then divide by 2 and then multiply by 16. Or you can divide the 16 and the 2. Thereafter, it's 90 in the brackets times 8. 8 times 0, 0. Then 8 times 9, it's 7, 2, which is 7.20. And you say meters. So to calculate the distance during the time graph, you need to identify the shape which has been formed. After you identify the shape, Then come up with a formula that you can use to calculate the area. So the distance under the speed time graph, you will say distance is the same as the area of the region which has been covered. That's how that one goes. C. Speed of the car when t was 53. You are calculating the speed of the car when the speed, when the t or when the time was 53. Kamba, we are here. This is how the, just to illustrate the movement, we said it was like this. Like that, and then like that. From here, we said it's 8. This is now 40. No? This is 8, right? Then from here, it was 40. Meaning, here it's what? 48. Correct. Then the last was 10. Meaning, we are only, come on. 58, correct. So why have we done this? We were told that the object started from rest and moved for t, but t was 8. It then maintained that speed of 16 for 40 seconds. So from 8 add 40. That's why we have reached 48. Then from 48, decelerating in the last seconds was 10. So that's why we have gone to 58. Are we safe? Okay. So we have been told to calculate the speed when t is what? 53. So that's why I was saying last time that when the line is like this, it means the acceleration is the same from here up to here, as long as the line is like this. So same case, this side. As long as the line is like this, the acceleration is the same throughout here. So where are we expecting to find the 53? Within this region, right? So calculate first the acceleration. So you will say acceleration equals velocity final minus velocity initial over time. So first come up with acceleration. We know you want to calculate the velocity when the t is 53. But first, identify acceleration, because at the moment you do not know the speed when t is 53. Are we there? Yeah. We just know the speed when t is 8, it is 16. But what about when it's 53? You are not aware. So you are not aware of two things within the same formula. So at the time given, we are supposed to calculate this one when t equals 53. So it's within this region. But again, we do not know the acceleration of this region. So we do not know 1, 2. Are we there? But we can calculate acceleration by using any 2 points, the upper one and the lower one. So let's calculate acceleration. After I've calculated, we come and replace it, because t will be 53. Then the acceleration will be the value which we have found. Then initial will be 16, since it will be going down. Then that's the final we want for velocity. We are there, huh? So at the moment, we have been given to calculate the velocity when t is 53. T has been given. Initial is 16, since t is going down. We are starting from 16 and going down. But you don't know that down, that is the v. Again, we do not know the acceleration in that region. So let's first calculate acceleration. So acceleration is the same formula. So in the last region, we can use the velocity, which is Pamunu here. Velocity final will be this one down, which is 0. So our initial is 16 velocity, and then it is coming to rest. So our final will be 0. Our initial will be 16. Then our t, from here up to here, it was 10. That will be our t. I'll go again. We want to calculate the acceleration so that we can come and replace it. But the acceleration through this line, it is the same. So we can use the last point and the first point to calculate the acceleration. There's no problem. As long as it's along the line, it will be the same. We go. Final, it is where it is going down, 0. Minus initial, where it is starting from. Where is the velocity starting from? 16. And then the t in the last, just follow the last, where you started from to where you ended. The t was told to be 10. Like that. So our answer is the negative 10 over 6. It is negative because it is going down. So 16 over 10, which we can reduce to negative 1.6. So that is our acceleration for the last part. So that same last part is the one which contains t53. The same last part, it is the region where there is t equals 53. Now we come back to this question. Acceleration, we are going to put that one, or you can write negative 16 over 10, which can be reduced. 2 on top, 2 into 16. 8, then 2 into 10, 5. So we have reduced it. That is the acceleration, right? So let's not be confused. Then, final, at the point where t will be 53, here we are, upper. You don't know the velocity, right? We don't know the velocity, but we know that t is within this region. So, velocity we don't know, we'll say v, minus initial. It started from the top here, 16. That's when it came to that point. So it is still 16 here. Then t has been taught. When t was what? 53. But don't put 53. Do not put 53. Put the time you are using. You are starting from 48 and reaching what? 53. So do not put t53. It will be very wrong. Just know what time have I covered. Are we there? I emphasize. Yes, they have said T53. But what time have you covered T? From here up to there. Come on. T equals the 53 seconds, yes, minus the 48, which is 5 seconds. So all the seconds are going to put for T. Are we there? In the presence of the Lord. Like that. These guys, this is a single fraction. This is also a single fraction. And then they are the same. It means the top are also the same. Because you cross multiply this one, it will come here. You cross multiply this one, it will come here. But you can also divide them again. So whenever you have got a single fraction on one side of the equation and a single fraction on the other side of the equation, and then the denominators are the same, simply eliminate them. I'll get the point. So here we just forget them because single fraction, same. Forget about the bottom. Just say the top are equal. Just say the top are equal. So wrap here. So from there we just say negative. Like that. We just forget about the bottom. From here, know what to move. This guy will move to this side. It will be positive 16 now. And when minus 8. V. V equals 8. meters per second. And for sure it is true because it is below. It cannot give you a larger number than 16 because the velocity is below. So that is the case there. Nishi, you are done. Any questions? Feel free to ask where you have not understood from A, B, and C. Yeah,